All right. So it feels worded really weirdly in here. And the reason for that is because it's exactly the way it's worded in the homework. So when we say find a standard equation or the standard equation, we're just meaning find an equation. And since I have a vertex, what we're going to do is we're going to look at vertex form. So, I'm going to do this. Our vertex form of a quadratic, that's our same thing as our transformation form. A x minus h squared plus k, this guy. Our vertex is what values? H and k. My ID. There's no b in this one. I mean, you can put a b in there, but we don't have information about it. Like the b would go right there. So this is HK. Thank you. So what we have at this point is a x minus -3 squared plus k, right? Plus 1. Ta-da. That is the equation for any parabola that goes through that point that has a vertex. Maybe it's got an a value of 7 and it's really, really tall and skinny. Maybe it has an a value of 1/2 and it's really, really compressed. Maybe it has a horizontal reflection and it has a b value, but it doesn't change where the vertex is. Maybe it has a negative a value and it goes upside down. That is any parabola that goes through that vertex. We're just going to leave the a as the any. The a also covers the b transformations as well because it's just a horizontal reflection versus a vertical. So you don't have to have both in the any. So that's how we do those. Okay? They just look all kinds of weird because they wordily said don't put in an a. Okay? So we're going to try that again just so we can practice it again. Find the standard equation, meaning find an equation, for any parabola that has a vertex of 0, -2. Same vibe. We're taking our vertex form. We're going to plug in our h comma k. Y equals a x minus 0 squared plus k, so -2. You can write it like that. I don't really care. It's extra writing because this is really x squared minus 2. Again, that A transformation takes care of all of our reflections or stretch or compresses. Because if we think about it, a B transformation on a parabola just makes it line back up with itself, so a B transformation doesn't do a whole heck of a lot on a parabola. It just makes it spin. Oh my gosh, it is hot in here. So this is the first class I've been moving because my headache finally went away. Yay. Okay. So naturally, the whole section of the homework is not going to be quite like that. I know. It'd be nice, but it's not. So then what we have is we are asked to put this into vertex form. And you have a couple of options. Option 1, complete the square. I was expecting significantly more groans with that. We did that a bunch of times when we were looking at circles. I was opening this because it's like 95 degrees in here. Oh my gosh, I am dying. It is hot in here. So option 1 is complete the square, which you guys can do. We did that a bunch of times with the circles. There is an easy way. Because the easy way to find a vertex, find your axis of symmetry. Our axis of symmetry, I actually have the formula on my board right now because my Algebra 2 kids are doing that too. That's when we take, it's the before the plus or minus in our quadratic formula, negative b over 2a. That's how we find our axis of symmetry. So let's do that. That gives us the x value of the vertex. It spits it out for us. So x equals the opposite of b. What's the opposite of b? Over 2 times a, negative 2. So what's the x value of our vertex? Negative 2. How can I find the y value of the vertex? Plug it in, substitute it in, like into the equation. So we're going to do f of, we're going to practice this notation because some of us struggled with this on the homework. F of negative 2, we're going to substitute in our minus 2 into our f of x. So we're evaluating f of x at negative 2. So we have the opposite of negative 2 squared. Minus 4 minus 2, or times minus 2. Plus 8 minus 5. What's the y value for our vertex? Negative 1. So our vertex is the point negative 2, negative 1. It's easier than completing the square. But if you like completing the square, more power to you. Absolutely fine. We'll get you the exact same equation. So we're going to write it. Now we're writing the equation through this vertex point, just like we did. Except this time we're not looking for any equation. We have a specific one. What is our a value? Negative 1. It is the exact same a value as is right here. Negative 1. That's why the a's are the same between all the forms. The a is the same between all the forms. So this is our a, same a. So y equals our a of negative 1, x minus our h, which is negative 2 squared plus k minus 1. If you like completing the square like we did in circles, you can absolutely do that. Totally fine. That is the technically way that the book wants you to show it, but this is way easier and it gets you to exactly the same answer with less calculation. Yes, dear? Same vibe, same thing. The a is the a is the a, which is in why all the quadratic forms, they use a in that same place, because it's the same term. Okay? We're going to try it again. Because it's been a minute since we axis of symmetried. Yes, I used it as a verb. Because grammar is a construct. We're going to try it again. Here's our new equation. F of x equals minus 3x squared minus 6x minus 5. So we're going to find our axis of symmetry. We find our axis of symmetry, x equals negative b over 2a. That's the formula for the axis of symmetry. It's the before the plus or minus in the quadratic formula, because I know sometimes that's easier to remember than to remember a whole new formula. It's negative b, still divided by 2a. It's before the plus or minus. So for this one in particular, the opposite of b is going to be positive 6. 2 times a is negative 6. So what's our axis of symmetry? Negative 1. To find the y value for that vertex, we evaluate f of x at negative 1. So we're substituting it in. Giving us a little throwback in here with this notation because we struggled with this a little bit in the homework. Minus 3, substituting in our minus 1 in place of the x. Minus 6, substituting this in place of the x. Minus 5. Minus 1 squared is what? 1. So we have minus 3 times 1, which is minus 3. Minus 6 times negative 1 becomes plus 6 minus 5. So what's our y value? Negative 2. So our vertex is the point negative 1, negative 2. What is our a value? Negative 3. That's our a. So we can write this into our vertex form equation. Y equals, or f of x. I genuinely do not care. Negative 3. X minus the x value from our vertex of negative 1. X minus negative 1 becomes x plus 1 squared plus k minus 2. That's our solution. There's writing it into the vertex form. We're doing excellent on time. Yes, dear. Because we had this negative 3 times negative 1 squared. Negative 1 squared. There we go. Boop. Oh, totally meant that to be a smaller dot. Boop. There we go. No, when in doubt, ask the question. I'm always happy to explain it. Absolutely. Ready? Okay. What's up?
How much harder though? Is it still fun?
I'm going to say deep breath.
Oh, okay. Oh, okay.
Okay.
Oh wait, that's not terrible. It doesn't look that bad.
I mean, it's fraction. We always get a little panicked when we see a whole bunch of fractions.
At least they all have the same denominator.
They do all have the same denominator. But it's the exact same vibe. Same vibe. So we're going to start with finding our axis of symmetry. our axis of symmetry, that's our negative b over 2a. So the opposite of b is 12/5 over 2 times a, 4/5. Does anyone see a shortcut to make this easier real quick? Yeah, they're both fifths, so remove the fifths. Thank you. Remove the fifths. They cancel out. So what we have is our axis of symmetry happens at 12/4 or 3. That's not too bad. That's not too bad. Now we got to go find the y value of our vertex. So we're going to do f of 3. Two fifths times 3 squared minus 12/5 times 3 plus 23/5. Fifths. Always feels like you're chewing on it. I mean, saying it right, but it still feels fifths. It's too much tongue action going on. Like, it's a whole lot. Fifths. So when we simplify this, 2/5 times 3 squared. No. 3 squared gives us 9. 2/5 times 9. 18/5. You went too hard. Minus 12/5 times 3. Minus 36/5 plus 23/5. Fifths. Gives us what? 40. The 18 and the 23 will give us the 41 minus 36. 5/5 or 1. So it was fractiony, but everything came out to whole numbers. Yay! So our vertex point is 3, 1. What's our A? 2/5. That's A. So we can write our vertex form. I'm going to do it way up at the top. 18 minus 36 plus 23 will give you 5. Because all of our denominators are the same. We can just do our operations on the numerators. That's why I opened the window. It is hot in here, and it's only 63 degrees outside, so it should cool off. The bottom button. Well, yep, that one. So it's minus 36. It's minus the 36. You've got a positive 36. Also, use scrap paper, not my desk. Okay, so you had your signs switched on there, which is going to make your numbers go weird. Positive 18 minus 36. You did 36 minus 18.
Oh, so that makes that gets a negative answer.
Yeah. Okay. So our vertex form is going to be our y equals 2/5 x minus 3 squared plus 1. Oh, that's terrible. Let's try that slightly more legibly. There we go. That's less awful. Okay? We feeling okay on the getting it in a vertex form? All right, because now what we're going to do is we're going to start smashing a whole bunch of stuff together. Because we're going to be aiming to get a sketch. We're not graphing here, we're just getting a sketch. We're going to find a vertex, we're going to find our roots, and we're going to give a quick sketch. We are not graphing purely, we are not finding a table, we are not plotting a whole bunch of points. We are making a sketch. So we're going to find a vertex, we're going to find some roots, we've got a y-intercept. How we have a y-intercept? C is your y-intercept. Okay, so they tell us specifically to use the quadratic formula to find our zeros. So let's do that. X equals opposite of b plus or minus the square root of b squared, 4 squared, which is 16, minus 4 times a times c, 36, over 2 times a, which is 2. And I'm 100% okay if you just like write it that way. Like, that's plenty for me. If you want to write the whole thing out, that's fine, but that's a lot of writing. So this becomes -4 plus or minus square root of -20. Quadratic formula. Yeah, quadratic formula. We just didn't write all the steps out in between. We did some of it in our heads while we were writing it down because we hate to write every single step. Stop drawing on my desks. Just saying. It is a recurring problem in all of my classes. Like, people are doing full-on, like, art projects on my desks. And I'm the only one that cleans these tables.
I'll clean them for you.
I'm the only one who cleans these dang tables. Like, nobody even picks up their shrapnel from cutting. Shrapnel. I know, you guys probably did the best of all of my classes at the shrapnel pickup, but that doesn't mean it was good. It was just better than the chaos and confetti left by my Algebra 2 classes. Because they oftentimes leave me actual confetti. All right, so what are our roots? Simplify this the rest of the way. What do we get? -2. Well, what'd you pull out of the 20 to make it? We pulled out, yeah, because it was a 4, so it was a 2. So what's left over? 5. I square root of 5. Because it's negative. Yeah. Yeah, because 20 is 4 times 5, so we pull out a square root of 4, which is 2. The 2 cancels out. We're left with I square root of 5. So what kind of roots does this have? Imaginary roots. So is this going to hit the x-axis? No. So this has imaginary roots. So then we're also asked to find the vertex so we can sketch it. So just what we did before. We're finding our axis of symmetry so we can find our vertex. So we're going to take our negative b over 2a. So -4 over 2 times A, axis of symmetry. Sorry, I'm just lazy, and if I try and write symmetry that many times, there will be a significant error in the number of M's. So I put AOS as a way to prevent spelling errors. Over 2. There's just too many next to each other bumps, and it just becomes a squiggle. AOS is the axis of symmetry. So the x value of our vertex is what? Negative 2. To find the y value of our vertex, we plug it in. Negative 2 squared plus 4 times negative 2 plus 9. So we get 4 minus 8 plus 9. What's the y value? 5. I just heard it come from enough places that I was confirming. So our vertex is the point negative 2, 5. So when we go to make a little sketch of this, I'm just going to do this. I'm going to do it way up here. Negative 2, 5 is somewhere up here. It's my vertex. We know we have imaginary roots, so it's not hitting the x-axis. It's going to go like that. And it has a y-intercept at 9. We get that from here. That is an entirely sufficient sketch. We are not graphing. Like, don't count. Give me just label the information we've got and move on with our life. We're going for ish. A sketch is ish. Okay? You don't have to, but you can.
Why didn't we do the quadratic formula?
They specifically told us to find our roots. I mean, we can tell from the fact that the A value is positive that's going to open up. We've got a vertex. We've got a y-intercept. Genuinely, I don't know why we have to, aside from practicing the quadratic formula again. But they did a thing. What was your question, Addisol?
I was going to say go up because I thought like you had more up there. But
Nope,
never mind.
I don't.
Okay.
I just wanted to check and make sure. Okay. We are in such good shape time-wise on this. I'm really happy. All right. We're going to do one more like this and then we're done. Like for the day.
No way.
Yes way. It's just like this one. So we're supposed to use the quadratic formula to find the zeros, find the maximum or minimum value of f of x, and sketch. Maximum or minimum value of f of x just means find the vertex. So same exact vibe that we just had. It's just bigger numbers, so the quadratic formula gets a little ugly. But again, this is one of those that generally I'm looking for the sketch, and I'm genuinely not sure why they're making this quadratic formula something this gross. I really don't know. So if you can do it without the quadratic formula, I'm okay with it. Y'all have quadratic formula enough times in your lives. Y'all know it by now. I've seen you guys do it. I know you guys know how to do quadratic formula.
Oh,
Then practice it. No. I will make sure of that. Because I looked at this during my notes and I went, ew. There was a full 2 syllables on the ew. It was ew. So I'm 100% okay with us going on the quadratic formula on this and going ew and sneaking a calculator to do it on the homework because no one's watching. Because I totally did. And apparently the new course director for IU is not as strict about the calculator thing. We can't change the rule for this semester. but I'm going to be a little bit nicer. And I'll make sure that we don't have gross things like this on the test. I don't know. Because they're telling us to. Genuinely, I don't know why. I don't even know why they're telling us to. They just told us to. And so I'm just like, but it doesn't. It just tells us where the roots are, and they're irrational, and so it doesn't help anyway. We don't.
So there's not a quick one.
I don't think so. And even if there is, it will be nicer.
Yeah, but it has nothing to do with the answer.
I know, I just don't have a copy of the test. I don't have a copy of it yet. So we see it. It's on the homework with these instructions.
Friday.
Next Friday.
Next Friday.
Yeah. Yes, dear. Uh-huh.
Which one, like, what's the answer?
Let's find the vertex.
Oh.
I have news about the quiz for tomorrow, which once we finish with this, it'll be just a second, okay? So let's do we'll do our vertex. We've got a vertex, a y-intercept. That's enough to get a sketch for me. So we're going to have our negative 16 over 2a. You could do the quadratic formula. More power to you. But then again, for the sketch, I don't think that we need it. So negative 16 over negative 4, positive 4. Our vertex is at what point? These numbers are big and a little bit gross. So we're finding our vertex. We're making a sketch, and if we can find from our a value, our y-axis, or our a value, our y-intercept, and our vertex, I'm okay if we skip the quadratic formula when it's going to give us gargantuan numbers like 16 squared. So what's our y value for our vertex? It is 6. So what we have is a vertex at the point 4, 6. Is this going to open up or down? Down. How do we know that? A is negative. What's our y-intercept? Negative 26. We know that from here. It's our C. C is always your y-intercept. Swoop. Swoop. It's a parabola. We're sketching. We're not going for a proper graph. I'm not going to come try and read the roots off of a sketch. That is a bad idea. If you do the quadratic formula, if you really feel like it and getting froggy with it, it is 4 plus or minus square root of 3. That would be the extent that adds on to our sketch. It changes nothing else but gives us labels on roots. Okay? So that is end of notes today. And for the quiz, we're not canceling it. No. We are going to do it as take home. Take home.
Wait, the what is this?
The quiz for tomorrow.
Yo, so we're taking it home tonight.
So I'm giving it to you tonight because you don't get to take it over the weekend. I'm not that nice.
I can do it.
So I'm going to give it to you right now. Do it tonight. Turn it in tomorrow.
Why are you so high?
Huh?
So high.
Covers a lot of stuff. And honestly, how the heck would I verify that? I mean, try. See if you could have done it in class. How hard is it? kind of why I passed back all the homework so we can double check against what we've done. There we go. Updated. Which means we have time to slow down on tomorrow's notes because we need that too. Our chapter test is next Friday. I will get you guys the review as soon as I can.
Yay.
Okay?
Wait, so the thing is due tomorrow.
The quiz is due tomorrow.
Come in.
Put it in the bin.
Okay.
We're taking notes tomorrow.
This is so fun.
So you're not going to have time in class to work on it.
Oh my gosh, I love this.
I'm dropping
Okay.
for second semester though, like first semester.
That's
So like if I drop out like the end of first semester,
Uh-huh.
I'm still gonna get like a dual credit. Or, like,
I don't know. That would be a Ms. Ballin question.
So
Okay.
like and for the course, like you said it was out of order. So is it out of order for the semester or out of order like do the
I genuinely don't know. This is my first year with DC and my first year with Precal in general.